down by terms, could someone share with us how many terms does this expression actually have? How many terms, Malachi? 4 terms. Nice. And then they asked you to group them into like terms. Is there any like terms?
Yeah.
Oh, yeah.
Yes.
All right, give me a pair of like terms. No, sit down.
So messing around with Malachi, messing around, not walking around the room, you never get yourself to be prepared. You waste so much time.
Autumn?
2n, negative 2n and 7n.
All right, so you can group your n terms together, and they can be like terms. Is there any other? Tom?
Negative r plus n.
Yep. Now, I'm going to have you guys do one more step that I know that's not on in the little box. Now, I'm not asking, but if I did, if I said simplify this expression, what does that mean? First of all, think about what simplify means. Lucas, what does simplify mean, hon?
Like add the like terms together.
Yeah. Just put them together. Because right now we have 4 terms given to us. I've asked you to break it down by terms, which you told me was 4, right? You eliminated a list, right? Is that what you did? Separate by commas, right? We've done that. And then you put the list of terms into pairs of like terms. We had 2 pairs. And now if you put the like terms together, think about it. If you put the 2 like terms together, what's our new n term? Autumn?
5n plus 9r.
Yeah, so if you put the n's together and the r's together, our new expression, instead of having 4 terms, we're going to make it 2 terms. Isn't 2 smaller than 4? That means it's simplified. Remember, when you simplify fractions, don't you make the fractions numbers get smaller? Top and bottom? Right? That's basically what it means. All right, just like what Lucas said, you put the terms together, and that's what makes it smaller. Okay? Any questions? So any of those 3 things that I've asked of you in that little scenario can happen anytime. You should be able to do those. I believe that was the first couple problems on your last test. Okay? All right. Put this away, and then if you would, get out your notes. Have your homework out on your desk. I will come around when I have time, within the class time, to pick up your homework. As long as your name is on it, make sure your name is on it. Just put it up in the corner. I'll have Mrs. Soul just come around and pick it up as I am teaching. So make sure that you're paying attention. Make sure you have the note sheet. The first slide should look like this. Yeah.
I did
All right, everyone ready? No, leave your homework on top of your desk. Huh? This is okay. This is a better way. Okay. All right, now, what I'm going to do today is introduce you guys to a couple different scenarios that you can find with equations. Obviously, my last class, we got through the 2 different scenarios. I have 2 more scenarios kind of to go through tomorrow, and we'll finish up then. And then hopefully we can move on to some word problems and such. So, this is what's going to happen. First of all, I want you guys to look at this problem. And I want you to box the variable term. Raise your hand if you notice something. Kenna? Yeah. What else do you notice on that side? Do you notice anything else? Charity? There's 2 constants. You guys want to know a rule? You want to know something? Before you can create a 0 pair, before you can get rid of multiplication, before you can get rid of division, before you can get rid of any fraction, before you can start any process to find x. Remember what I just said about simplifying? Remember what I mean by simplify? You have to simplify both sides. In order to start the process of solving for x, before you can start, you have to make sure the left side of the equation has no more than, listen to me carefully, one variable term and one constant. And that goes for the right-hand side too. You do that first now. Starting today, anytime you see an equation, you have to make sure that the left side and the right side has no more than one variable term and one constant. You can have less than that, but you can't have more than that before you start the process. Okay? Do you guys agree the left-hand side violates that rule? So we have to do what? Simplify. Combine like terms. Huh, coinky dinky, we did that on our bell word, didn't we? And that's what you're doing. Okay? We're going to put all the terms together that are alike. So in this case, you guys hopefully boxed those two x terms. If you put those two x terms together, what would be our new variable term or x term, Angelo?
2x.
Excellent. Now, could you put the two constants together? Because those two terms can become one constant or one number. Dylan? Now look at what we got. Does that look familiar? Could that problem end up on your homework last night? Have you done a problem similar to that before? Sure has. So what I'm trying to tell you is that from today forward, any equation, and as we move into the next chapter, which is called inequalities, you have to make sure that when you compare the left side to the right side, you only can have one variable term and one constant, okay, on either side. You can have one of each on each side, which you've never seen that when a variable term has been on both sides, right? Okay, we haven't got there yet. That's next year. That's not me. I get to wash my hands of that. All right, don't have to teach that anymore. But for you guys, you have to make sure it looks like that. You should have two operations only. And then that goes back to your two-step problem. Go ahead and solve this. Go. On your own. All right, you guys ready for me to try it? You can compare yours with mine. And if you've started the check, please wait, okay, for the check, because these are going to be different. And I want to make sure I make a point, okay? So in this case, I'm going to create my zero pair first, okay? Everyone okay with that? And then this term goes bye-bye, so all I have is 2x is equal to negative 16. We got the signs right? All right. Now the only operation I see left is multiplication, and we all know that we use division in order to get rid of multiplication. And this time I'm going to divide by 2 in order to get 1x there, because 2 divided by 2 is 1. X is equal to negative 8. Hopefully you agree. Now this is the time where I talked to my other students and I said, now listen, I do make you check. And some of you probably hate that I make you check. Well, to be honest, it only helps you that you check your work. It makes you feel more confident coming in every day knowing that you did something right. You also figure out on your own, which is a huge deal in a middle school environment. Young adulthood is figuring things out on your own. Do you want to have somebody else think for you, or do you want to think for yourself? I believe as teenagers, you don't like what adults say, period. But think about it. You get to figure out if you're doing something right on your own. Okay? You check your work. If the check doesn't work out, you go back to your work. Did I get my signs right? Shoot, that's supposed to be negative. Now it works. I see it all the time on your work. I see you guys change signs because you went back to your work. You figured that out. I didn't have to do that for you. The sooner I don't have to figure that out for you, you can figure it out on your own. Whew, huge. That's huge. As a mathematical student, let me tell you. Okay? I still have to hold people's hands in middle school. It's kind of embarrassing. All right. But it's the way it goes. I want to ask you, when we plug our x back in for the check, do you think we plug it in here or the top? Which one do you think? What's your gut instinct tell you? Bryce?
The top.
Why?
Doesn't have like all the numbers.
Oh, I've also told you if I type it, that's where you plug it in. But what do you think? Why do you think that? Why do you think I'm going to make you do this versus this right here? Think of what could happen from here to here. I bet you've done it before. Dylan?
You might make an error. Like bring it down.
Yeah, because what if you don't have this right? And you don't get this right, you plug it in back here, you're going to get the check right. You see what I'm saying? This X will check out here. And you're going to be like, Miss Noms, I got it wrong though. Well, where'd you check it? I'll ask you. Where'd you check it? Okay? If you don't go, because the thing is, if you put 9x and negative 7x and you said this is negative 2x, this becomes a positive 8. It works out. You plug it back in. Oh, it works. Yay, you got it right. But if you plug that positive 8 back here, it wouldn't work. You see the problem? You always go back to the original problem. That is, I always went by, if it's typed, that's what I use. If I handwrite it, I don't use it to check. Okay? Remember, I always give you either worksheets, if it was out of a textbook, it's typed. Is it not? That's where you check. That's where you go back and check. If any of your handwritten, I know that a lot of you copy the problems on your paper, always go back to the worksheet and check it from there. Okay? Because a lot of times, sometimes, do you ever write the problem wrong from worksheet to your paper? You're all guilty of that too. Okay? You forget a sign, it throws everything off. Okay? You can do the whole process right. One sign, change the ballgame. Told you that from the get-go. All right, so what we're going to do is I'm going to show how you can maybe help yourself here. We're going to plug this in. I have not a lot of room up here at all, so I'm going to try to do this as best I can. All right, so we have 9, and everywhere the X is, we're going to plug a parentheses. So we're going to add 1. We're going to subtract 7 times our X minus 5 has to equal negative 20, correct? We got to put our what?
That's on check.
Correct. Can you multiply?
I can't find
Can you multiply? Can you add? Can you subtract? Those are the only 3 operations I see on the left-hand side. If you can do that, guys, if you put your hand over this, isn't that just a big long gems problem? That's all it is. Now I'm going to let you combine some things. Let me just show you. Simplify it here a little bit. All right. So look, we have 9 times negative 8. Do you guys agree that we're going to multiply before we add or subtract? Okay. So what's 9 times a negative 8? Okay. So negative 72. All right. We're going to add 1. Now, this is equal to 20. I can't fit it there, but you get it. All right, so now we still have addition, subtraction. We have multiplication. You guys agree this is multiplication? When I see parentheses next to a number, it's multiplication. So what do we do next? Add, subtract, or multiply? Charity? So what's a negative 7 times a negative 8? Positive 56. We haven't used negative 5. We haven't used the 1. And we haven't used 72, which is negative. And 72 is off here somewhere. It's off the table. Sorry. So now, I'm going to have to plug that. I'm going to have to squeeze that in there. So we have 1 plus, come on. I can't get that in there. Oh, now it works. Oh, right on my board. All right. Come on. What the heck is that all about? Okay. Let's see if this works out. Oh, there we go. All right, so we have negative 72. We're just going to keep putting stuff on there and racing and see how much we can hit on there. All right, so let's try this again. Plus 1. Oh, my goodness. Negative 7 times negative 8 is positive 56.
Is this recording?
Yeah. Watch it back, laugh a little. Hey, a little entertainment at home. All right, now, you guys agree that this is what's left, right? Okay. Does anybody remember what we can do from here? Do we have to go left or right?
No.
Remember the red day and the blue day? Remember when we circled all the negatives and all the positives and we just grouped them together? Okay? So from here, we can just take all of our negatives. What's 72 negatives and 5 negatives make? How many negatives? Negative 77. How about take our positives and put those together? How many positives total do we have? 57. Good. Now those two have to make 20 negatives. Does that make negative 20? You guys agree that our sign 77 is negative 77 is the largest absolute value, so it's going to be negative, and the difference between 77 and 57 is 20. So it checks.
That's a big.
Can you go get a drink of water or?
Mr. G-Shrek's here.
Now, this is a little bit intense check. You guys agree? It's a lot more steps, a lot more reasons that, you could make mistakes if you're careless, right? Okay. So, I'll make a couple deals with you. Make sure that you be patient. Don't sit there and you can complain in your head all you want. Just don't let me hear it. Okay? Otherwise, my deal goes right out the door. Okay? So I do have a deal for you at the end of class. Just simmer down. Go get your panties in a rumble. Okay? All right. Somebody told me last hour that they had no panties on. All right. So, whatever. I was like, TMI. Thank you very much. No.
Oh,
No. He needs to focus. All right. Now, I want you to try this problem, please. Again, remember what the rule is. How many variable terms can you have on a side? How many constants can you have on a side before you start the equation process? Okay? If you can remember the rule, hopefully all of you did this. Because how many variable terms can you have on each side? How many? 1. You guys agree? 1? All right. Now, what operation do we have? After we combine like terms on the left-hand side, we make those negative 5x's and 13x's turn into 8x. What is the only operation left in the problem now? No, I don't see division. Multiplication. We use what to get rid of multiplication? Division. Good. So I'm going to divide by 8, and x is equal to negative 8. Now, again, when we do our check, okay, we have 2 multiplication problems and an addition problem. That's all we have. So what is negative 5 times negative 8? Positive 40. Nice.
Is this the check?
Yep. And now 13 times negative 8. What do we got? Autumn?
112. Oh, negative 112.
No.
Should be 104, kiddo.
Why?
Because 13 times 8, 8 times 3 is 24.
Oh, I did 32.
Yeah, that's one more. That's one more 8. All right. So now look at these two. Which one has the largest absolute value? 40 or negative 104? So our answer is going to be negative. What's the difference between these two? Hopefully 64, because if it's not, I did it wrong. And I haven't done something wrong in a long time. Just kidding. Just kidding. I'm human. I haven't run a girl over in her pink bike yet this year. All right. Just watch when I'm driving. You get out of the way. That's all I ask. You never know what's going to happen.
That's what that was.
I pull out of the parking lot. I see kids laying in the middle of the road on an elevator. I don't. Oh, I didn't see you. I don't. What am I going to do? Actually, I stop and I pull over and I tell them to get their rear ends out of the road. That's what I tell them.
Oh my gosh.
I got in my car one time.
Like you just saw a kid.
I parked my car off the side of the elevator. You know when a big group of kids walk? Got out of my car, walked over to the two boys that were messing around.
In the middle of the
Angelo,
elevator room.
and he wasn't him. He knows who I'm talking about.
And Tom.
I asked if he needed an escort to walk home. I'll escort him home. Make sure he's not going to get in any trouble.
All the way there?
I care about Hector. I don't want him to get in any trouble, so I just asked him. He goes, no, ma'am.
I wouldn't. Wait, so you were just standing in the middle of the elevator room?
No, he wasn't. He ran across, and his friend was sitting on the side of the road, like in the gravel. So Hector wasn't doing anything wrong. It was his friend, but Hector was the one that was like, no, ma'am. Hector's a cool kid when he wants to be, right? Right, Angelo? Yeah, he's a good kid. All right, now we're going to switch gears here. So the first two, you're going to see some combined like terms. So remember, always one variable term, one constant before you can start any process. The other type of equation that I need to make sure that you're aware of that can happen and can come across is obviously equations that have parentheses in them, which means you have to apply a certain property that we've used in our past. Okay? Now, if you look inside this, you guys agree that x, you can't get to x the way it looks right here. Do you guys agree? X is stuck inside the parentheses. In order to get x outside of the parentheses, we have to use the distributive property. Anybody remember how to use it? You remember? Dylan, what do you do, hon?
3 times 4 by x, and then 4 times 5.
Good. And this obviously kind of reminds you of that. Okay, this slide right here. It tells you you're going to take the number which is outside the parentheses, which is this 4 right here, and you're going to distribute, which means, remember, what's a number next to a parentheses? What operation is that? And that's why you said multiply. You're going to take 4, multiply it by 4x, and get a new term, which is 4x. You guys read 4 times x is 4x. Okay? And then you're going to take this 4 and multiply it by this 5. What's 4 times 5? 20. And you're going to add your 20 on.
40.
It's okay. Simmer down, Tonto. Okay? Thank you. Tonto's, remember I told you, Lone Ranger's horse. Okay? So, look at the problem now. We haven't talked about it.
Is it?
Kimosabe was his Indian friend. Okay, look. Look at the problem. Once you've gotten rid of the you use the distributive property to get rid of the parentheses. Could you solve it from here? Doesn't this look like a problem you had last night? So each of these types of equations, you have to do one thing to get them back to what you did yesterday. All right? So one little step, distribute, and you're right back to where you were yesterday. And from here, do you really need my help anymore?
No.
No, many of you can just boom, boom, you're done. It's quicker for me not to go through it, right? You can just do it quicker than I can with the class, all right? So we're going to skip, I'm not going to go through this whole problem. We're going to go, because like I said, I want you to practice this distributing, getting to a problem that looks like this, and then I'm going to show you how to check this. That's the one thing that last class, Ms. Holmes, how do you check this? How do you check it? Because you are going to be required to at least check some. I didn't say all, but some. so can we go on to the next problem, and then when we get to a certain, I'll check one with you to help you. All right? Because really, if you look this, if you plug your x value into the parentheses, all it does is become a GEMS problem with parentheses. Do you know how to simplify a GEMS problem with parentheses? Sure you do. You've seen parentheses and GEMS problems, haven't you? All right, so let's just distribute this. What would this equation be without parentheses? What would it read right here? What would the equation be without parentheses? Okay, Cheyenne?
Division. No.
Angelo?
36 equals 6x and negative 30.
Do you all agree with that?
Mm-hmm.
We move on to the next one, and then we'll check that one. We'll do that whole one together. Is that good? Okay, so you practice a couple. I mean, if I asked you to go back and do these, you could, correct? Okay. So let's go to the next one. And if you would, right now, change this 9 to a 10. Otherwise, you're going to be wanting to throw stones at me, and I don't care to do that. All right, so could someone share with us, what are we distributing? Charity? The 2. And we're going to distribute a 2 to 2x, 2 to the negative 5. Are we going to distribute a 2 to this positive 4 out here?
No.
Why not the 4?
Because it's not in the parentheses.
Yeah. Yeah, the only 2 lucky numbers are 2x and negative 5. They're the lucky ones. They get to distribute another factor of 2 to them, but positive 4 not included. Remember, the parentheses is a groups things, right? So positive 4 is not in the group. You get it? You know, it's not in the group. Huh. Lost you?
Yeah.
Are you guys still in grandmother's little forest you can't find her house?
Yeah.
Pretty much. Mm-hmm. When I distribute a 2 factor to 2x, 2 times 2 is 4. 4 times x is x. For 4x, excuse me. And then 2 times negative 5 is negative 10. We haven't added 4, so we're going to add 4 down here. Can we start?
No.
What's wrong with the situation?
There's 2 constants.
Yeah, you can't. Remember, 1. Only 1 can be on a side. Okay? 1 variable. We have 1 variable, which is good, but we have 2 constants. So Malachi, when you put the 2 constants together, what do you get?
-6.
Yeah. All right, from here, I want you to solve, I solve, and then stop once you get to x, and then we'll check together. All right, go. If you haven't done so already. Some of you guys are getting a little too good for your oh, good. Huh.
Oh. That was close.
What?
Nothing.
What do you think I was going to say?
Nothing.
I can't believe you'd think that. You have those types of thoughts about me, Malachi? That's not very nice. What? Don't say it out loud. It's not very nice. Nice one. What, Peyton? A little smirk on your face. Look at that. I haven't done anything to you yet today. I haven't even called on you today. How are you? Good. You made it to my class on time. That's a good thing, man. Glad you made it. You guys ready for the check?
Yep.
Everyone check? Everyone good? It's like walk in the park. You do these in your sleep. You're good. Old news, right? All right, so we're gonna plug this in. We got. I'm gonna do this up top if you don't mind, so everyone can see. So look, we're gonna plug in our x. I want you to watch me first. Look. Look at how I set this up. Is that not rewriting this whole entire thing with where x was, just putting replacing with the parentheses? Okay. Now we're going to put our x value, which is what? 4. Now, look. If you cover equals 10, does that not look like a gem problem with parentheses, a grouping symbol? Have you ever done those before? Yes. What is the rule with gems? What do we have to do first? What's the G stand for? You simplify the grouping first. So what do we have to make that parentheses? Go down to what? How many numbers have to be in there? 1. So we have to get that down to 1. So let me do this. Let's do this. We got 2. Inside the parentheses, we have 2 times 4, which is what? 8. 8 minus 5 is what?
3.
Couldn't you do that all in one step? Can you multiply and then subtract in your head? I think most of you can do that. Okay? So if you want to simplify that parentheses into one step, make it easier for your check, that's fine. I'm okay with that. Okay? So now we're going to add 4. That has to equal 10. Now look at what do you have left? Multiply or add? Which one? So what's 2 times 3?
6.
What's 6 plus 4?
10.
Yeah, we check out, we're good. So the check is not that hard if you look at it. If you look inside, if you just focus inside those, those parentheses, it's really just a multiplication and a subtraction problem. You've done those the whole time. You're just making, now we're doubling it. What?
Look, if you have homework and you copy the problem on a piece of paper,
You always go back to like the worksheet and then check it from here.
can you put like that on another piece of paper and do all the checks on it?
Yeah, that would be perfect because then you could, yeah, that would be awesome. A lot of kids have done that. Just so that they can keep their checks and their problems separate. That's what they do. Some people like their check right next to the problem. It's what you prefer. I'm not a picky person. I'm just happy that you do the work. I ask.
So you don't have to do the check?
What are you talking about? Are you crazy? Are you lost? Have you come off the Google desk or what? No, I didn't. I fell off the Google desk. All right, now into this room. Hence you're all with me, so look what you're gonna end up being. All right, so. Cuckoo for chew. All right. Any questions on any of these? Tomorrow, we're going to start with this situation. We have not touched this, where we just had a negative sign. We touched it earlier when we had distributed, but I'm going to review this tomorrow. Is that cool? And then we'll move on to this tomorrow.
That looks scary.
And this one. Remember what before you get your little panties in a bind, remember this. What have I always told you about a fraction? A fraction is a multiplication problem, Autumn, and a division problem in one. Look at 2/3. Do you know how to multiply by 2?
Yeah.
Divide by 3? You just distributed 2/3.
Oh.
Watch this. I'm going to show you. Tomorrow you can do this. What's 2 times 6? 12 divided by 3 is? 4 times x is? 4x. You just distributed 2/3. That's smart. In your head. Okay? So, I'll blow your mind tomorrow. Bring them attached, but I will blow your mind. It's amazing what you can do. Now, get out your worksheet. I'm going to have you guys do a couple. Dabble here.
Hey, what's that deal you said you were going to make?
Malachi, thank you for reminding me. I'm not senile yet. I will tell you in just a second. On the side that says distributed property, if you would, I want you to circle these problems. Number 1, number 3, and number 4. Now, this is what I'm going to deal. You guys agree that all of them have distributed property, right? Mm-hmm. You can check them all, or check 3. Number 3. Now, this is what I'm telling you, Angelo. If you like to know that you're doing them correctly, and you can check them all, because you're only going to get 6 problems tonight. You're not getting a lot. Okay? This is what I recommend. This is what I would do if I was you. I would check them all. But for those people that I'm just going to keep it at that. You can fill in the blank there. You can check number 3 only, if you wish. But I'm going to tell you, I would check them all. Moving on to the other side. Circle number 3, number 4, and number 7. You can, obviously, my recommendation is to check them all. Hence, you only have 3 problems on this side as well. Okay? And you had a lot more problems last night. So, I want you to check at least number 4. I'm going to tell you this. Warning. Like, have you ever seen, like, a warning on a label?
This is the warning. This is Mrs. Alm's warning. You get any of the 4 problems that you did not check wrong. What do you think I'm gonna make you do? Redo them and check them.
So if you get
And
one
guess
wrong,
what? I'm taking the deal away.
oh, so if you get one wrong.
Mhm.
Check.
Yeah. I'd rather check them. Okay? The thing is, guys, you know, I understand that you don't see some of you in here don't see the purpose of the checks. And I know you guys talk to other students. I know that other teachers don't require it. I've done this a lot longer, and I know where you're headed. I've taught Algebra 1 for years. Okay? That's freshman year. There's certain teachers at Huntington that do not allow you to use calculators. Which means, during the equation unit, do you think you might want to check your work to make sure you're doing them correctly? Do you know how many students that come back and thank me for making them check their work, even though they griped and moaned and you know, and probably gave me the bird once in a while? But listen, hard work does pay off in the long run. You will understand that when it comes time to understand it. Sometimes you don't understand what adults say to you because it's not the time to understand it. Okay? When I became an adult, I look back at my youth and went, I was wrong. Okay? So guys, listen. I make you do things, obviously, for a reason. There is purpose. I've taught 8th grade for years. I've taught Algebra 1. I've taught the next 2 classes you're going to take. Mandatory. Math is mandatory. You have to pass it. Okay? When you get to high school.
Oh, yeah, do it.
So this is what I'm trying to tell you is, even though I require a little bit more from you, in the long run, it's going to pay off for you. Okay? Trust me, if you don't, you can keep doing what you do in your head all you want.